Okay, it's not going to let me do it because it's frozen. I don't know how it unfreezes. You guys. Oh, there we go. Thank you. All right, so now I would like you guys to take and fill in the table of values for 2 plus 2 cosine theta for these same angles, and take a minute and see if you guys can do that, and then we'll work on graphing that one on the other grid that you have 2 extra grids, so we'll try it. I usually go to the hundredths, just because it's easier to kind of graph, but really to the tenths is accurate enough if you run it to the nearest tenths. On the test, I won't take off for hundredths or tenths, but at least 1 to 2 places. Is there enough light for you guys to use your calculators? It won't let me till I start recording again. Then I will. Just give me a minute, let everybody fill their charts out, and then I'll start doing it with you. So far, do you guys understand what I'm doing even though I'm recording it? Okay, do you find patterns in the chart? You know, at some point you can see they kind of start to repeat. On that first chart, you know, you could see that it went to 0 and then it went to 1 and then it went, you know, it went back to 0 and then it started the negative rotation and then came back. So there are some patterns that you can pick up in many of them. Some of them there's a lot more patterns than in others. On the test, I'll give you one equation. It'll only be one, and you'll have to fill out the table of values, and there'll be one graph sitting there for you to fill in. Okay, I'm going to go ahead and play it, and you guys can check. Okay, so you should have your table of values, and I'm going to try to keep it all in there so that they can see it on the screen. I probably didn't make the screen quite big enough for it, but you can see the table of values. Check your table of values and see if those are the values you have down there. Are they? Just get those values. Okay, so if you didn't, you need to go back in there and plug them in. Did you get the very first one at 4? You need to go, okay, so you need to check. When you get to 15 degrees, you need to take the cosine of 15 degrees, times it by 2, and then add on 2, and you should get 3.93. Okay, what's the largest value in the chart? Absolute value. 4. You've got a 4 here. It comes down smaller to 1, goes back up, and then back to 4. So 4 is the largest value. That means this time, I'm going to scoot this table over to this side so you can see it. When I'm graphing this point, I need this outside ring to be 4. Ms. Clark said the outside ring has got to be the largest value in the chart. Okay? If you take 4 and you divide it into thirds, all right? A third of 4 is 1.3. That means this first ring should be 1.3. And then the second ring will be twice that, or 2.7. It's like 2.66666, or 2.7 about. And then another 1 1/3 goes out to, I think it just quit. It might be too long, but we'll keep going. Add on another 1 1/3 and you'll get to 4. Okay, so each one of them is about 1 1/3. Okay, so on the test, I don't care if all of these are labeled, but I do care. The one thing you have to label are going to be the rings. And the outside ring has to be the largest number that appears in the chart. Is that clear? What you have to label on the test. Okay, so now I'm going to plot these points. So at 0, we're going to be all the way out at 4. And I know you can't see it. It's right off the screen there, but you'd fill in a dot on the 4 out there. Then 1.93 will be just inside it. I think 3.93. 3.73. At 45, we're going to be at 3.41. And again, I'm guessing about where that is. Then I'm going to be at 3, which is getting close to 2.7. And then I'm going to be at 2.51, which is less than 2.7. And then I'm going to be at 2, which will be right in here somewhere. So those are where the first ones go. And again, this one looks like it might be off a little bit because it doesn't line up with the rest. I kind of adjust them because I know this needs to be a smooth curve going out here to the 4. Should be a nice smooth curve. And I usually do about 1/4 of them and then connect them all. Okay, so I'm now at 105 degrees, and at 105 degrees I'm at 1.48, so it's still coming down. And then 1, and then 0.58, so now I'm down inside here, and 0.26, and 0.07, and then at 180 I'm down to 0. So it's just going to loop right around, and again I messed up on this one right here. They're all off just by a smidge. And I can tell when I go to connect them because they should smoothly loop right around in there. And I had a couple of them that were off there. I put 2 of them on 120 degrees, and I can see I did that. I had to move it over there. Okay, so I'm down to 0. Now I'm going to move it. I'm going to do the 0.07 as I'm at 195. So at 195, I'm going to be at 0.07. So right here, then 0.26, and then 0.58. I'm going to sneeze. 0.1. I mean at 1. 1.48. So I'm at 255. 1.48 is going to jump up above the 1.3 ring. 270, I'm at 2. 285, I'm at 2.51. Whoops. 300, I'm at 2.73, so just a little bit above it. Oops, I'm not. I'm at 3, aren't I? Sorry, my fault. I was reading the other one. 2.513. I'm going to move it up a little bit. I'm at 3.41. 315, 3.41, 3.73, 3.93, and then 4. So this one's going to loop right on around. And come back out at 4 where it started. So this is like a cardioid. They call this a cardioid. It's supposed to look like a heart. If I turned it sideways, can you see how it somewhat looks like a heart like that? They call it a cardioid, okay, because it looks like a heart. This is a sideways heart. Some of you might think that looks like a lily pad, which it kind of does, but they do the one with the little loop on the inside to be the lily pad or the limicon, and this is a cardioid because it looks like a heart, okay? So at least now I think you guys can try to do them. We will see how you guys do. And I'm going to let you try the ones that are in the book.